Okay, let's go. So good morning, good afternoon, and good evening, every participant, and thank you for joining us at this demo showcase, which takes place during our participation of all digital CES show. So just to present the intervenants, I'm Mélanie, I'm business developer at Jarnoux and I'm with Julien, which is, I'm not sure that's you.
On the other side of the room. Hello, everyone.
Your webcam is connected, but Julien is here, and he will have an amazing demonstration of our solution just after. So Julien is our R&D manager. Very short introduction regarding the agenda for this meeting. I will present you briefly our company, and I will let the mic to Julien to go through a global presentation of our solution and then a live demo of the power of EGOS. And at least we will have a question and answer part to ask us anything you want to know more.
Just one thing about that, don't hesitate to ask any questions on the dedicated menu on Teams application. They won't be public by default. We will try to go through at the end, or depending on how this showcase goes. And yeah, if we don't have time to answer all your questions, please don't hesitate to come back to us afterwards. We'll do our best to answer your questions.
Okay, thanks, Julien. So just to introduce our story, I want to come on the fact that you may already know that actually there are more smart systems than humans in the planets. Everywhere you need to collect, to transmit data. So for example, there you get a city and also an airport. That's most common example in the world. But actually you can also duplicate the scenario in many other use cases like cities, farming, industry, IoT sectors, transport, defense. Everywhere you need to collect and to transmit information, you can find some IoTs. And those systems are embedded with more powerful software to provide intelligent communication, low power consumption, high security level, and also relevant information. We can identify new smart projects a little bit like a connected iceberg. Today, programmers have to write thousands of line codes to develop the complex software, which is take place into those kind of software systems. They have also to take care about the several environments and specification of the industry. For example, the autonomous, the mobility, the range temperature, or harsh conditions they have to go through. During the last years, it's about 60% of the projects that have been cancelled due to a lack of knowledge, a lack of budgets, or lack of time. That's I call the hidden face of the connected iceberg. We identify during the last years 3 different kinds of key success that will achieve to go through a new smart devices. First, that's an acceleration. You need to go fast to the market to get the right customer. Then it's the agility. You need to move your product into the market's usage and asking. And then the security. You need to avoid any intrusion into your system to be sure that you will provide the right answer. Jarnoux have been created 2 years ago to meet the needs and requirements of the industry of IoT. We are part of the Scat group, of the digital cluster of the Scat group. We are actually 10% in the team, and the Scat group offers us 40 years of experience in IoT knowledge. Our projects have been subventioned through 5 million euros of investment to go through EGOS projects. Just to have a little overview about the Scat group, actually they are not only focusing to IoT systems. There are about 10 companies who works into different expertise into digital and mechatronical technologies. It's about mechanicals, optronics, productions, many different fields of application, and we are able to work all together to follow our customer into their own product deliveries, from the specification to the production phase. Just to tease you a little bit about our solution developed interior cogénère, so I don't want to spoil Julien. Oh, sorry, they have some issues, but we have developed a software solution that accelerates and secure the time to market for new smart design. So our mission, okay, let's go through, but it's okay. Our mission is to reduce the time to market by 50% for the development. Go back. Yeah, okay. Sorry about that. I got a mistake with my slides. That's okay. So our mission is to reduce the time to market for new devices creation rather than traditional design methods. And also we incorporate natively some functionalities to be able to secure and deliver higher quality of service into the systems. To get back to the key success I presented you to previously, with EGOS, we are able to develop a new embedded application within only 60 days. So we want to help our customer to accelerate, to have access to their markets. We are totally independent from the hardware platform, so we offer some agility to move into different kind of products, and at least incorporates safe and secure by design from the first line code of EGOS to be sure that the product will not be have some intrusions into their deployments. Last year, we developed our products, EGOS, over different kind of projects and products. That I want to show you into this slide is we are able, with the same software package, to address many different use cases like asset tracking, metering, or some specific use cases like tilt detection or robotic systems. And just to finish, I want to thank you, our partners who have accompanied, who have followed us during our creation. They are industrial, academic, and institute partners who help us to test and validate our roadmap onto EGOS. So thank you for them. And I will let the mic to Julien if you are ready to present everything.
Yes, I am. Hi, so my turn. I will briefly introduce you to our solution, which is called EGOS. I will present you the main principle we based our solution on, a little overview of our architecture, the software architecture of EGOS, and of course the main part of the demo, which will be a live demonstration.
Yes, sorry.
One more. So we based EGOS on 6 main principles. The first one is the ease of use. Our goal is to provide you a complete IoT software toolbox, which allows you to really take hand on your device and exploit, use every functionality you have on your hardware. So it's, when we talk about EGOS, we think about like an OS, and that was the main idea of it. But when we think about it, we go much farther than that, and we provide not only the OS, but also the middleware and the SDK. I will come a little bit afterwards about what are these middleware and SDK. We also provide a lot of utilities library, which provide a lot of basic utilities which you normally redevelop on your own for each application you do, but these are already provided within EGOS. And for those of you who will be interested to develop really code something within EGOS, we provide advanced programming macro, which could be interpreted like DSL. DSL is for domain-specific language. It's like a language within a language. So the development language is C, but with all macro, what we get if you use EGOS is really some high-level functionalities, which whether you use C or whatever language it is, you don't care. Just use this macro, and it does most of the job for you. The second principle is the security. Of course, you are aware about the cybersecurity threat which we are facing today. So we took care of being very cautious about that, and what we did is, of course, following the state-of-the-art coding rules, which should be the base for every software development today, but it's not always the case. We use a static analysis code tool, which is called Sonar, to check our software regularly. We use also a software development tool which is called GitLab. It's a DevOps tool, and we exploit every functionality provided. And as from the EGOS technical side, really deep side, we have fail-safe mechanisms. We also have guardians. Guardians are some kind of process which takes care of looking the other process and make sure that everything is going fine. And if not, then restart them and so on. So it's really internal functionalities within EGOS. And we have also a hybrid kernel. I won't get too much into details right now. It's not the purpose of this webinar, but it's for security reasons also. And we also hired one new colleague, which started, actually one year ago already, because he did his last training, engineering training with us, but he's now starting his thesis about cybersecurity within EGOS, as we intend not only to secure communications, but also the kernel itself, really the OS will be secure. So that's how we take security into EGOS. The third one, is the development time. As Mélanie mentioned already, our goal is to reduce your development time, and by that we provide not only the OS, but full feature sensors and modules. And when we provide a functionality, we provide all the functionality and not only part of it. As I mentioned already, we provide also utilities library, and we have also a complete hardware abstraction, which I will come back a little bit later, which allows us to, and you also to develop your application independently from the hardware you are using. We'll explain a little bit into more details later. The fourth principle is the independency. All EGOS code has been developed internally by our team at Rebroadcast. We are independent from every data and cloud platform. As you may have heard, Microsoft purchased Threadix, Amazon purchased FreeRTOS, so lots of GAFAM are really taking into their own area some of the most powerful kernel on the market. We are far from that, and we intend to stick like this. We claim our independency regarding that, and we are also independent from board manufacturer, although we comply with most of them. But that's something we are somehow proud of. The fifth principle is the modularity. So we based our architecture really in a modular way, so that we can develop one functionality without affecting the other. It's like the automotive world, the AutoSAR of the IoT. AutoSAR is the software architecture for the automotive. We intend to provide a solution which is the Autosar of IoT. So this is the fifth point, and the last one is our community. We have opened part of the code to external contributions. So if you intend to provide to support us in our journey, then you are welcome to do, and we provide you a GitLab platform to do so. We also, what we expect actually regarding this community is to help us develop driver. There are so many driver and sensor on the market that it's very tough to support all of them. And if we can get external support on that, it would be very much appreciated. So a very short introduction on the architecture of EGOS now. So the first one is the bottom layer of EGOS is the bootloader. As you are all aware, you need to maintain your device up to date, and that's why we provide a bootloader, wire, and also with over-the-air functionality to allow you to update your firmware, the firmware of your device. On top of that, there is the kernel, the real OS, the main part of the OS. So there's not only so within this kernel, there's test framework, utilities I've already mentioned, the program manager, as we intend to provide this. Our solution is intended for very low power devices, which can have an autonomy from months to years. We even worked on a project for which required a 12 years autonomy, which is quite huge. So we have a very strong power management constraint, and this is included in the kernel. We also have the OS services, of course, or the process management, the messages, and so on. I won't get into this detail right now. And all of that applies on a specific board support package, which depends on your hardware. This board support package is also split in 3 layers: the microcontroller abstraction, the hardware abstraction, and the driver implementation. So that's let's say, when we talk about the OS, this is what the OS is. Now comes the interesting part, is the above layer, which is the middleware. So the middleware is, it provides lots of advanced functionalities. When you think about the OS, they are all sticking to the kernel layer. Now, what we intend to provide with EGOS is also the middleware, which includes Scat Ltp, which is a secure communication stack. I will explain that just after this slide. We provide device management, communication protocol, of course, automation protocols, cloud platform connector, and so on. And when we talk about advanced driver functionalities, that's what is explained on the left side. It's, you have an accelerometer. Okay, that's fine. You can measure the acceleration of your product. Okay, but what do you really want in the end? You don't want the acceleration. You want to measure the tilt. You want to detect a shock. You want to detect a movement, a vibration, and all that kind of detection requires some specific algorithm and configuration of the accelerometer. It's always based on a simple accelerometer, but you need special algorithm to treat the information and filter them to get what you need. And that is what we provide within the middleware. So we not only provide the driver of the accelerometer, we provide all the advanced functionalities which allow you to really use this accelerometer without having to develop your own code. The other example is pretty simple. You have your GPIO, you want to detect a push button, but it can be a simple click, a double click, a mouse, whatsoever, and it's the same. We will provide all these advanced features within our middleware. And on top of this middleware is the user SDK. It's the so-called name of the part of our solution which allows you to simply configure your device. So that's really what we intend to achieve very soon, is to provide you so the embedded part, which will support all this configuration part. So what you will have to do is to just launch a PC application, a GUI, on which you will select the different configuration you want. You will be helped by several profiles which will already be set up. Like if you want to do geolocation, then you will have already settings already in place, telemetry, remote control, or if you want to customize everything, then you will be able to do so. And all these profiles, that's how we call them, will be simply applied to the device. So either by wire connection or again via DOTA. So DOTA stands for data over the air. So remote control of your device on which you send information using the communication protocol implemented on your device. And that will change the way your device behaves. So that's, in the end, you won't have to code anything. You will just have to configure it. And that's really what we intend with EGOS. Then I mentioned a little bit shortly about Scat Ltp. So Scat Ltp is a part of EGOS, which includes a secure and segmentation stack communication. So this stack communication applies only to LP1, so low power wireless area network, basically Sigfox and LoRa, which are the two main LP1 today. As you may know, Sigfox is not secure by default, and LoRaWAN is secure with AES 138. What does Scat Ltp is to secure everything with a very low overhead on the data, and it secures it with an AES 256 algorithm. So it's pretty powerful. And in addition to that, Scat Ltp allows to segment the data, meaning that whatever the size of the data your application needs to send, you don't care about the protocol you want to use, you simply send them, and then Scat Ltp will take care of segmenting the data. So as for example, I think on Sigfox it's 12 bytes per frame, so it will segment them in as many 12-byte frames it requires to be sent on the network. And then on your network side, on your server side, on the right-hand side of the slide, then you will get the whole frame as it was only one. We will, you will have a short demo about that afterwards. So yeah, that's it for the theoretical part of the demo. Now I will start the live demo. So let me share my screen. Okay, no, I need to. So okay. Yes. Okay, so now you should see my screen, and on my screen a little application, and I will explain shortly after. So I will also switch my camera, hoping it works now. Yes, it is. So on the screen, on the left-hand side, you see my screen. On the right-hand side, you see what is right next to me. It's the EGOS kit. So Mélanie presented it to you a little bit earlier. So this is a kit we provide, which is based on STM32 microcontroller. It's a Nucleo board for those of you know. In addition to that, you can find two modules. So on the upper part of your screen, you see the accelerometer, and on the bottom part, it's a microchip LoRa module. You can also plug a third module. So these modules are from Microelectronica, who provide up to, I think it's 800 sensors and modules on the same format. So it's the same bus, communication bus, and you can put up to 3 of them on this kit. In addition to that, there is also an FTDI chip which is implemented, which means that you simply need to connect it via USB to your PC, and you can use your favorite terminal to see the serial data which will be transmitted by the device. And that's what the current demo does. So it's a very simple PC application which receives the data from UART and provides in real time the tilt of the device, and it becomes red when it's up to than 45 degrees, I think. So this is, yeah, I mean, useful for POC development, proof of concept or whatsoever. That's what we used for an internal project last year, and that's pretty useful. So this is, yeah, a simple application I wanted to show at the beginning. Now I will show you a little bit more about the application, the Scat Ltp application. So I have here loaded my debugger, which is Ozone. It's a Sega tool. You can use ST tools whatsoever. I mean, it's communicating using SWD, which is very similar to JITAG for those of you who know. So yeah. I have already prepared a Scat demo, so I will just load it into the kit and show you what it will do. So I will restart. Okay, so now we see the demo, and here we have a log which appears on the terminal. So yeah, it looks like you can see it, so maybe you're not able to see, but yeah, these are debug information. I will explain a little bit later what these information are and how it's working. What is more interesting for now is the behavior of this demo and what it really does. So as I mentioned, it's secure the communication. So first, let's make sure that the communication works. So no, it's not the correct one. Yeah, that's the last one. So here on my screen, you can see the Things Network console. So the Things Network is for private LoRa network on which we register this device here, like you can see. And so I will simply activate the demo first. So let me just check. Okay, so now it's started, and then I will shake the kit, and you can see on the screen that it's trying to send a frame. And if we go to the Things Network, then we can see this frame being sent. So this is actually the join procedure of the LoRa protocol. So I won't get into details for those of you who don't know how it's working, but yeah, that's what it does. And here we can see the payload appearing, and it's in clear, meaning that the data are not encrypted, or actually they are via the LoRa protocol, but the application, the payload itself, is not encrypted. So yeah, okay. If I shake the kit too quickly, and I have to comply with LoRa duty cycle, which is set to 10 seconds for the demo, because otherwise it would be way too long for you to wait. So here, as you can see, I've increased the frame counter within my payload each time I shake it, and yeah, so if I do this another time, it should work. Not yet. But yeah, you get the point, and you can see the data in clear. But as I said, one of the goals of Scat Ltp is to secure the data. So how we do that? We simply change one line. So I'm just going through the line to show you how easy it is to adapt your application to your needs, and mostly to also show you the secure, and that I'm not cheating on anything I'm showing you. It's really real time. So let's hope the demo effect won't occur today. Okay, so now it's compiled. I will reload the application within the kit and restart it. Okay, so this is the demo. Okay, I have a small issue with this tool. I'm not sure why, but I'm quite used to it. So let me just kill this process and restart it again. Should work. Okay. I couldn't explain the reason why it's doing that. So let me, sorry for that. Let's restart. Okay, so now the demo is restarting. I need to activate pressing the button here, as you can see on the webcam. And I will send the frame. Now we see the new join procedure again. And the frame should shortly come. Yes, it comes. So here, as you can see, I just activated the secure communication, and from this payload, we are now having this one. And okay, it's fine, it's a payload, it's longer, you don't know what the information are inside, but I can show you that that's really the same. And as, let's say, a proof, I'm sending the second frame, it's just should increase the frame counter. But here you see the payload is totally different. So that's fine, you have an encrypted payload, but what to do about that? Then we can use our backend server, which is called Scat, which allows you to actually see the data of any kind, any network. And as you can see here, you can see all the frames I'm sending since the beginning of this demo. Not only, so the three ones, sorry, are the unsecured one, and the last two are the secured one. As you can see, the counter has been reset here, and it's being increased. And yeah, so if I press one more time, yes, it's already there, and here we have it here also. So Scat integrates a small executable which allows him to decode the Scat Ltp encryption, but that's a pretty basic integration to do, and that allows you to secure way more your communication that it does by default. So that's what I wanted to show you, and that's how Scat Ltp works. Now I will load another application. So it's smaller, or let's say a simpler one. For one good reason, I will explain shortly after. So I will just change one thing in the make file and delete some application file to make sure that it does not compile everything again. And recompile everything, or at least only the application. And I will go into more details about what EGOS is providing you, mainly the debug capabilities and stuff like that. So, and now the demo is ready, and I will restart it. So just before I start it, and to show you that it's a different application. Okay, on the top side here we saw that it was Scat Ltp demo application, and now it's an LoRa accelerometer application. So it's a really different one. I will restart again. And as you may see on the screen, the LEDs are not blinking anymore, and the button doesn't have any effect. It's because I removed the management of the LED and button, and I will stick only with accelerometer and LoRa module usage. You will understand shortly after why this is. So a little bit earlier, I mentioned this terminal thing here. You are well aware how a debugger works, but sometimes there is nothing better than real hard stuff, hard debug thing, and so you can put your TT Toto, I am here, I am not there, stuff wherever you want in your code, and you can use serial communication, as I will show you later. But what is nice with EGOS, and it's based on the ARM functionality, is we are using SWO, single layer output, which allows you to provide information already inside the terminal itself, inside, I mean, the debugger itself. The main interesting point here is that it's way faster than the UART debug. I've debugged application using a sending frame every milliseconds, and it runs quite well. I didn't lose any data. So that's really what this debug information is about. The second information, I've just paused the debugger so you can see it here. This information here, which I'm highlighting, are the memory consumption, so the RAM consumption in real time, meaning that if I let the application running every 30 seconds, but it's configurable, you will get the real RAM consumption of every process you have in your application. So don't take care of the value itself. These are the value of the RAM consumption, but that's really interesting when you want to debug an application. So this is natively integrated within EGOS. In addition to that, as we have a UART communication, we can use it to do another thing. When you want to debug your application, you sometimes need to change data on your own. So either you use the debug, change the variable inside if it's feasible, but it's sometimes not. So what we developed is a so-called console. Well, we name it the console, which allows you to communicate directly with your OS, with your product using the serial communication. So here I'm really using the serial communication. It still doesn't stop anything of the normal behavior, let's say, of your application. And what I've implemented here is a small menu which allows you to send a custom frame. That's what is written here. So I will select M1 to enter this menu, and then I will say, let's say I want to send 1, 2, 3, 4. I'm pressing enter, and then as you can see on the terminal here, it shows, okay, I will send 1, 2, 3, 4. But what is really interesting is that it actually sends 1, 2, 3, 4. So it really allows you to interact with your device as you were in. And so this is a basic example. You can do whatever you want, send whatever data you want, act on anything you want on your device. But at least you have the console engine, which is already available, and it's working quite efficiently, as you can see. And yeah, that's a very nice feature, which I'm using very often when doing some development. And one last feature which I will present you is to debug also, or to actually visualize the process you have implemented within EGOS. So here I'm using Sega System View, which allows you to really visualize the data which are provided by EGOS, and we have implemented within EGOS this feature. So because it's not something which is done by default, so here I'm restarting the application. As you can see here, I have reset the application. So, and on this system view, what you can see is the current process which is running, how long it is running, and as you can see, the duration are pretty precise. We are talking about microseconds, and this is done in real time for your application. So this is not, I mean, this is a known protocol, but what I wanted to show you is that it's integrated already within EGOS. So when we say we provide an OS, we really provide an OS, and all the advanced functionality you may be in right to have when you are using such product. So yeah, now that was for the main part. I will quickly show you how easy it is to port this demo on a different hardware. Let me just check that I didn't forget anything. No, not yet. Okay, so it's good. So yeah, as I mentioned, the OS is nice to develop your application on a prototype, so like this EGOS kit. But if you want to use a real piece of hardware, then it's of course possible. Of course, my debugger crashed a second time. I need to restart. Where is it? Where are you? Thank you. So I will disconnect the event kit here, and I will connect another hardware. So this hardware is a customer hardware. I won't go into much details. Just let you know that it has the same microcontroller, except instead of having 1 megabyte of flash, we have here 256. And it has the same amount of RAM. It has the same accelerometer, the same LoRa module, and some other advanced functionalities which we are not using here. Yeah, I forgot to plug the power supply here. So it's, as you can see, it's powered by the battery. The two cables are connected. Is one for the debugger and for the probe, and the second one for the UART. And now, what I will do is to compile the same application on a different hardware, so on this hardware. So as you can see here, we are compiling the same application which is on the screen, and except this time we are doing that on the so-called EGIoT. So let me restart Ozone. So Ozone is a debugger. All right. So now, as you can see, it's still the same demo. I need to change some of the settings. Okay. So I have switched the probe, and now I can connect. And so as you can see, I'm not using the terminal here anymore. I wanted also to show you how you can use a standard terminal to do so. So you simply need to open it, and I need to restart to show you. So here we are executing the exact same demo. It's so the provided information are the LoRa keys here, as you can see. What's nice also is that we are using the integrated device ID of the LoRa module inside, so we don't have to change our firmware depending on the device, and to change the key. The key are automatically generated automatically using the internal device, LoRa device. So it's the same application, but as its hardware configuration is different, you don't have the same, exactly the same list of processes which are running, but you have also this memory debugger, which debug information which are provided. It's working exactly the same way I've shown you earlier, except this time it's on the UART thing. So yeah, that was for the first one, and I even have a second and last hardware on which customer hardware. So this hardware is really different here, since it's neither the same microcontroller, neither the same LoRa module, since it's actually not a module. It's a SoC, system on chip. So let me just connect this, and yeah, here is the debugger which I connected earlier. I will just connect everything again. So this device is connected. So what you can see, so there is very few components on it. The main one is the chip itself, the SoC, which includes the microcontroller and the LoRa module inside, and the accelerometer here. and that's pretty much it. Normally this device is powered by a battery, but yeah, for the demo purpose, I didn't want to take any risk. So on my main screen, you can see that I have again changed the hardware. So it's now a new one, and of course the debugger failed, and the reason is I won't even be able to use the same debugger to load the application, since this piece of hardware, I mean the microcontroller, is the STM32WL, which is very new chip from ST, which has been released a few months, let's say, it's so new that the Sega tool does not support yet this chip, so I have to use ST tool to do so. I will simply go find the binary which I've just generated. So when I say I'm not cheating, it's a 646, and which I've generated the binary which I'm using, and I will load it. File is corrupted, everything is fine. Yeah, I need to simply reset first. If it wants to. Maybe I need to power my board. It works better afterwards. Okay, now it's working fine. I will download the application. I'm not sure why it says corrupted. Hopefully it won't fail. I don't think so. And yeah, I need to change again the serial port on which I'm communicating. I will reset. I think I just need to clear the buffer here. And here it goes. So again, we have different keys. And if we go to the things network, so I will go to my device list, and here is the device I'm working with. And so well, we miss the join, but if we move the chip, here we see on the debugger that the movement has been detected, and we can actually see the frame which is being transmitted. So it's working exactly the same way the two other demo works, but on a different hardware, and it didn't take more than a second to switch from one to the other. So of course there are some files which needs to be updated to change to adapt the hardware, but once you've done that, the modular architecture of EGOS allows you to really do whatever you want, and as you can see, it's pretty reactive and working fine. So yeah, that was all I wanted to show you with this demo. I hope you enjoyed it. I'm glad it worked fine, and I will let Mélanie share a screen again so that I can she can finish the presentation.
Does it work?
Yes.
Yeah, so thank you, Julien, for the presentation, and the demo show was amazing to see that it works very easily to move the EGOS powers from another to another. Just to conclude very fast, because we let just 5 minutes for the questions. We also provide some services additional to the software, so technical supports, also training and consulting to develop any more applications, and some development kits that Julien showed you before, and also a device management platform. So just to have a brief, we have a training session in a few days now. It's all online training and with all our teams. And you will receive also the dev kits to manipulate all the different software.
So one more word about this training session. So the goal will be for you to take hand on the application side. So we won't go into details about how the OS is working and so on. What we will allow you is to do your own application. So right now you still need to code a few lines, but we will show you how it's working, and within one day you should be able to take hands on this kit and do your own IoT device.
And thank you all of you to follow our presentation. If you have any question, you can write it into the chats or
contact us afterwards.
Contact us.
Yeah, I don't see any questions. One was if we are recording the session, and yes, it is. We will try to provide that within the next days. Yeah, I don't see any question. Yes, one more new questions. Good. Thank you for the nice word, and we are glad that you enjoyed. And yeah, hopefully we will be in touch soon. And yeah, have a nice evening.
Yeah.
I think we will conclude this meeting.
We will need to get home now.
Yes, 1 hour left.
Thank you so much, and have a nice end of CES time.
Thank you. Bye bye.
Goodbye.